Hey guys, Mrs. Traver here. We're going to do our notes on section 210.2.10.3. This is part 2 of 3 of the videos of this section. So we're continuing our work with radicals. And yesterday, or in the first video I should say, might not have been here yesterday, we looked at simplifying them and then adding and subtracting them. Today we're going to look at multiplying. So those are 2 different types. The first kind is more, they're pretty straightforward. It's kind of like the add subtract ones where we just multiply the things that go together. So my first example on these ones will look like this. 2 root 7 times 6 root 3. So again, this looks kind of like the add subtract ones. And with those ones, we tried to combine things that were common, and that's kind of what's going to happen here. So the 2 and the 6 are both on the outside, so those will get combined to be an 8. Actually, I'm going to put it below instead of to the right, sorry. So those will become an 8. And the 7 and the 3 will go on the inside to make a 21. And the last thing we want to do is make sure that our answer is simplified. So is there anything perfect that goes into 27? Hopefully we have our perfect list down. And let's have it at the ready for ourselves when we need it. All right, so we have this chart that we can use, all of our perfect squares. So again, we're looking for something that 21 goes into. The red ones are perfect squares, and none of these will go into 21. So it's all simplified there. So there's our answer. Let's do another one. How about one like this? If we had the square root of, actually let's do 3 square root 6 times root 18. So stuff on the outside, we got a 3. We don't have anything on the outside with the 8, so there's like a 1 there. So 3 times 1. And on the inside, 6 times 18 is 108. And then again, we're looking at perfect squares. So what goes into 108 that's perfect? So we want to check our chart. So let's see. We'll check 108 divided by, it's definitely not any of these big ones. Maybe 49. Nope, that doesn't work. 108 divided by 36. 36 works. That's got to be the biggest one. So 36 and 3. So this is 36 times 3. And then that 36 is perfect, so we can break it out of jail. And it's had some good behavior, been perfect. We can break it out, and now it's going to be a 6 when it comes out. So on the outside, we've got 3 times 6 is 18. And on the inside, root 3. Let's do one more like that. So let's see, if we had, let's throw some variables in the mix. Square root 2a times the square root of 9a cubed. So we have some options here, by the way. We can simplify in the beginning or at the end, but if we do it at the beginning, we might end up having to simplify twice. So I usually do it and then just check it at the end. So let's see. There's nothing on the outside to combine. Everything's on the inside, so everything's going to go onto the inside. So we've got the square root of 2 times 9 is 18. That's a to the 4th. And now let's mess with this a little bit and see what we can do. What's perfect that goes into 18 is 9. So 9 times 2. And then a to the 4th, we want these to be written as squares. So we can go a squared, a squared. So then anything perfect comes out. 9 is perfect, so it's going to come out as a 3. A squared is perfect. It'll come out as an A. A squared is perfect. It'll come out as an A. So my 3 times A comes out. And I'm going to write 3AA as 3A squared. And then the only thing left on the inside is the 2. So this is the first type of the multiplying we've done with like radicals. Let's do another type. So I'm going to come down a little bit. All right, our next one is multiplying with distribution. So let's see. These ones we're going to have to do like our distribution arrows in. So our first one's going to look like this. We'll have root 10 times the quantity, root 6 plus 3. So let's see. We want to distribute. So this square root 10 is going to get distributed into here and here. So we've got 2 things we'll multiply. So first time, square root 10 times square root 3. I'm sorry, square root 10 times square root 6. They're both under the radical, so they can get combined into root 60. Square root 10 times 3, those are separate. The one's inside, one's outside, so I've got to leave it one inside, one outside like that. The last thing to check is if anything can get simplified. Let's look at our 60 and see if anything perfect fits into it. Let's kind of think through our list. 49, too big. 36, too big. 25 doesn't fit. 16, does 16 fit? Let's check. Nope, 16 doesn't fit. 9 doesn't fit. 4, oh yeah, 4 will fit. 4 times 15. So let's make this root 60 be 4 times 16. And then the 10 we can't do anything with because there's no perfect square that fits into it. So let's see what we can break out. 4 is perfect. We can break it out as a 2. And 16 is also perfect. We can break it out as a 4. So here we don't have anything left on the inside. All we have is on the outside 2 times 4 to give us an 8. And then our 3 root 10, we said we couldn't simplify at all. So 8 plus 3 root 10. Let's do another one like this. Let's say we had square root 2 times the quantity root 3 plus 2, root 5. All right, so let's see. This square root 2 is going to get distributed here and here. So let's see, root 2 times root 3. They're both under the radical, so we can combine them into a root 6. The other ones, root 2 times 2 root 5. So this 2 is the only thing on the outside, so it can stay. And then the 5 and the 2 kind of go together. 5 times 2 is 10. We can simplify it all we will, but there's nothing perfect that goes into 6 or 10, so we're done on that one. Let's do one more. All right, our last one then we will do like this. Let's do 4 root 5 times the quantity 12 minus 3 root 10. All right, so notice I've been kind of progressing on the outside here and here. We are distributing a radical. Now we're distributing a radical with a coefficient. So when we distribute, we have to be careful. This whole thing is getting distributed into the 12 term and into this 3 root 10 term. So be careful that you're looking at terms correctly. This is one term, not 2. All right, so 4 root 5 times 12. We can multiply the things that are on the outside together, 4 and 12. 4 times 12 is 48. And then the root 5 is the only thing on the inside there. Then we've got 4 root 5 times negative 3 root 10. So the things that go together are 4 and negative 3. We can combine those to be a negative 12. And then root 5 times root 10 is root 50. We'll see where we can simplify. So root 5, that can't get simplified at all. But this root 50, we can simplify. Something perfect fits into it, and it's 25. So I can pull that 25 out. And when it gets broken out of jail, it was perfect. So it gets broken out as a 5. So we've got 48 root 5 minus, that looks like 12 to the 5th. That's not what I meant. I mean 12 times 5, which is 60. And then all that's left in this radical is a 2. So 48 root 5 minus 60 root 2. There is one more type of these problems. The last type is when we're multiplying radicals, and they happen to be found inside 2 binomials. So whenever we multiply binomials, as a reminder, we are going to be FOILing. So that's what's happening here. It's just that when we do our 4 multiplies, first outside, inside, last, some of the things we multiply will be radicals. So let's do the first one here. Root 6 times root 6 is, we're both on the inside, so they can get combined to root 36. Then we have root 6 times 9. One was on the inside, one was on the outside, so they can't get combined. We've got 9 root 6. Then we've got I inside. Negative 2 times root 6 is just negative 2 root 6. One was on the inside, one was on the outside. And then last, negative 2 times 9 is negative 18. Once we're here in FOIL, like usual, we have some combining and some simplifying to do. So let's go term by term. Here's our first one, root 36. We can simplify that because there's something perfect that goes into 36, and it's 36. So 36 is perfect. We can pull it out as a 6, and there'll be no radical left there. So that's just a 6. Here I noticed both of these have the same radical. So like we learned in the first section in day 1, you can combine those. So we have 9 of these minus 2 of these. That means we have 7 of them. So we have plus 7 of these root 6's. Then I'm just going to drop down my minus 18. One more simplify to do. 6 minus 18 is negative 12. So negative 12 plus 7 root 6. Let's do one more of those. Say I had, let's do 2 root 11 plus 3 quantity squared. So the first thing to notice here is that we have a quantity squared, which basically just means I have 2 root 11 plus 3 times itself. So I can write it out twice. That way it's a little easier to see my FOIL. So let's do that with the first outside, inside, last. So here's my first, 2 root 11 times 2 root 11. So I can do the 2 times 2 to give me a 4. And the 11 times 11 is inside the radical. 11 times 11 is 121. O is outside, so 2 root 11 times 3. Outsides are 2 and 3, so that's a 6. And then root 11 is stuck on the inside. Inside, 3 times 2 root 11, 3, and root 3 and 2 are on the outside, so that's 6. And root 11 is on the inside. And then last is 3 times 3 to give us a 9. We'll look for some simplifying again. So let's look at our first one. We've got a 121 inside a square root. That was made up of 11 squared. So this whole thing was perfect. It's going to come out as an 11. And then my 2 inside terms, again, I can combine those. 6 root 11s plus 6 root 11s will give me a 12 root 11. So let's see, we've got 4 times 11 out here, 44. And this is, we said 12 root 11s. And then dropped out our 9. Last combine here, 44 plus 9 is 53 plus 12 root 11. So that is all the multiplying that we have. And then in our next one, we'll look at rationalizing the denominator. That's the trickiest of all the sections, so we'll do that in part 3. So stay tuned for that.